SSH keys are used as a very secure method for server authentication. Keys can be easily generated by running the SSH-keygen command. If you then hit enter 3 times in succession, the keys will be created. Note that this is the most common way of generating SSH keys, and will place your keys in their default locations and create them without a passphrase. SSH keys created are placed within the .ssh directory within your home directory. If you view the contents of this folder, you will see the private and public keys. The private key is ID_RSA, and the public key is ID_RSA.pub. Note the permissions set on the folder and keys. The .ssh folder and private key are both only readable and writable by the current user, while the public key is readable by any user on the system. Let's check out the private key, ID_RSA. You must never give out or display the contents of your private key with anyone. This is your secret, the equivalent of a password. Now look at the public key, ID_RSA.pub. Feel free to share your public key with anyone, or any server which you would like to authenticate with. You may also edit the last part of your public key after the space. This is treated as a comment to document which public key this is, and can be helpful when keeping track of many servers using different keys. Once you have generated your SSH private and public keys, the next step is to copy the public key to the remote server you wish to authenticate against. There's a simple helper command that makes this really easy called SSH copy ID. Let's type SSH-copy-ID, followed by the username of the user you wish to SSH as, followed by an @ sign, followed by the IP address or hostname of the remote host. You'll most likely be prompted for a password. Once you type in your server password and hit enter, the SSH key will have been copied to the remote server. To confirm you can SSH into the remote server with your SSH key and without a password, just type SSH username @ remote host and hit enter. You should now be SSH'd into the server without being prompted for a password. Since SSH copy ID is just a helper script, let's find out what it's actually doing in the event we wish to manually add keys for authentication in the future. After SSHing into the remote host, go into the .ssh folder within your home directory. Within that folder will be a file named authorized_keys. This file contains a list of public SSH keys which have been granted access for authentication. We can see that our public SSH key has been added to this file. To allow another user to authenticate to the server, just copy and paste their public SSH key into this file and save it. Once complete, the user that has access to the associated private key will then have access to connect to this host machine. To SSH into a remote host, we will use the SSH command. When using the SSH command followed by just the IP address or hostname, the command will assume the same username of your host machine for authentication. That's usually not what is desired. To use a specific username, prefix the remote hostname with the desired username followed by an @ symbol. This is the standard way to SSH into a remote host, and most times this is all that is needed to authenticate. Sometimes SSH servers will block connections on the default port 22 for security reasons and bind the SSH server to a different port. Let's assume the SSH server is bound to port 2022 instead of port 22. We add a -p flag followed by our port number 2022. Another command flag that is important is the -i flag. The I stands for identity and allows us to specify a different SSH key to authenticate with. This makes it possible to set up any number of different SSH keys to connect to any number of different hosts. SSHing into a remote host drops you right into a bash shell, but you may just want to run one command and immediately exit. Instead of dropping into a bash shell, you may specify a command to run after typing in your connection string. This allows you to run one-off commands, a quick bash script, or anything else you wish without needing to create and stay within an SSH session. An SSH config file is a very elegant way to connect to an SSH server. This config file provides the ability to connect to SSH servers much more simply, so you don't need to remember the intricate details surrounding an SSH connection. Let's create a file at tilde/.ssh/config. SSH config files follow a very simple format. They start with a host directive, which is the host name you wish to use for this connection. Every other directive specified within the block is optional, but allows you to fine-tune the connection details if you wish. Let's indent the following lines 4 spaces and add a hostname directive. This directive overrides the above host value and allows you to use any alias you wish for the above host value. You can now try SSHing into the remote host by typing SSH username at hostname, but instead of typing the entire hostname when SSHing into the server, just use the alias. This is so much easier to remember, but let's see if we can make it even simpler. Go back to your SSH config file and add a user directive. This is where you can define the user you wish to connect with. You can also specify the SSH key you wish to use for this connection by using an identity file directive, followed by the location of your private key. This is useful if the SSH key you wish to use is different than the default SSH key on your machine. All directives here are optional, so you can pick and choose the ones you wish to use to customize this SSH connection, such as specifying the port you wish to use. When all of your directives have been set, you can SSH using just the alias specified for the host directive. The SSH client will use the SSH config file to assign all of the directives specific to the SSH connection. The SCP or secure copy command is very similar to the CP or copy command, but allows you to copy files to and from a remote host. Start by echoing foo to a file named bar.txt. To use the secure copy command to copy the file to the remote host, type scp followed by the file you wish to copy, in this case bar.txt. Then specify your username at remote host connection string and suffix it with a colon. After the colon is where to tell scp where to copy the file to on the remote host. In this case, copy it to the home directory. By default, scp will use your default SSH key to connect to the remote host. To specify a different SSH key or identity, use the -i flag followed by the location of your SSH private key. If the remote SSH server is bound to a port other than the default port 22, you can specify a -P flag followed by the port number, in this case 2022. You can also copy entire folders recursively with the -R flag. Let's make a foo folder, then create a bar.txt file within the foo folder. We can then recursively copy the entire foo folder with the -R command. To copy a file or folder from a remote host back to the local host machine, specify the remote connection string first, followed by a colon, and then the location of the file or folder on the remote host you wish to copy. The second parameter is where on our local host machine you wish to copy the file to, with // being the current directory, and a new file name if you wish. Let's say you are on a network connection which is blocking access to a specific website. You can easily get around this with an SSH tunnel and local port forwarding. The -L flag is what tells SSH to open a local tunnel. The value of this flag is the local port you wish to use for the tunnel, followed by a colon, followed by the website host you wish to access, followed by a colon, and finally the value of the port you wish forwarded. In this example, you will forward the local port 8000 over to yahoo.com on port 80 of the remote host. Lastly, specify the SSH server you wish to tunnel the connection through. This is the server where the final request will be passed through. When you try to access yahoo.com on your local machine, what happens here is that the request on port 8000 on your local machine is being passed to the remote host, and then to yahoo.com on port 80 of the remote host. The result is then forwarded back to our local port and host. You can use this method to get around internet firewalls, as well as connecting to blocked remote services. Note that the SSH tunnel is keeping a terminal window open. If you specify a -F flag, it tells SSH to run in the background, and a -N does not open a shell window. Since the SSH tunnel runs in the background, you can look up the process by using PSAUX, pipe to grep, followed by SSH, or the port of the tunnel. To kill the tunnel, use the kill command followed by the ID of the running process. Another way to use SSH tunnels is to forward remote ports. This will forward connections on a remote host back to our local host machine. This is useful if a user wants to access your local host machine, but for one reason or another isn't able to connect directly to it. Note that remote port forwarding is disabled on SSH servers by default, so you need to edit the SSHD config file. It is typically located at /etc/ssh/sshd_config. Once open, set the gateway port's configuration value to yes. Then restart the SSH server by running service SSH restart. The command to establish an SSH tunnel is similar to before, but you use a -R flag rather than a -L flag. The first value defined is the port you wish to listen to on the remote host, port 8000, followed by localhost, followed by the local port that request should be forwarded to, in this case 3000. Then of course specify the SSH connection string of the remote host to use for the connection. Now if you load the URL on the remote host, or IP, on port 8000, it will tunnel requests to port 3000 on your local machine. SSH supports a number of functions through the use of an escape character, which by default is a tilde. Escape sequences are created by using the escape character, followed by another character that comes from a list of supported sequences. One of the most common escape sequences is a tilde. Sometimes an SSH connection will become frozen or stuck, so if you type tilde, it will automatically exit from the frozen terminal window. Another popular escape sequence is a tilde-Z. Say you wish to keep an SSH connection open, but you don't want to occupy a terminal window. You can issue a tilde-Z, and that will send the SSH session into the background. When it comes time for you to reconnect to the open SSH connection, type FG, enter. Once you SSH into a remote host, the server fingerprint and key are added to the known_host file within the .ssh folder of your home directory. This file contains a list of remote servers you have connected to in the past. The file ensures you are connected to the correct server and not a fake or impersonator. Sometimes if you try connecting to a new machine that has been assigned an IP address which you previously used to connect to another server, you will get a host mismatch error. This is because the remote host fingerprint does not match the record within your known host file. SSH into your remote host. What you will do next is get the SSH fingerprint of this machine. Type ssh-keygen-l-f/etc/ssh/ecdsa_key.pub. The -L tells SSH keygen we want the fingerprint, and the -F tells it where to find the host's public key. This is the typical location for Linux servers. What is outputted is the fingerprint of this machine. Now exit the remote host and run the command ssh-keygen-R and then the remote hostname or IP. This command removes all keys from the known host file on your local machine that belong to the specified host. Now when you try to connect back to the remote host, it'll ask you to confirm connecting to the remote host, and will also supply you with the remote host's SSH fingerprint. You can compare the output of the remote host's fingerprint to the output of the fingerprint that we are about to connect to in order to verify you are connecting to the desired remote hosts. SSH by default is fairly secure. However, there are a few configuration settings you can modify to make things even more secure. Open up the SSHD configuration file located at /etc/ssh/sshd_config. In this file, disable the ability to log into the root user by toggling Permit Root Login to No. If you would still like to be able to access the server with root, but don't want passwords to be used, you can also specify prohibit-password as the value, which will disable logins to root by password, but allow other connections with SSH keys. You can also completely disable password authentication for the entire server by setting the value for password authentication to No. Let's say you want to lock things down even further and only allow SSH connectivity for specific users. Search for or create the Allow Users directive. The value for this option is a space-delimited list of users or user IP connection strings. In this manner, you can lock down SSH for only specific users. You can also allow specific users only coming from specific IP addresses, or you can allow all users connecting from specific IP addresses. Be sure to restart the SSH service after applying updates to the configuration file by running service SSH restart. Connection attempts are logged to /var/log/auth.log. Open that file and you will be able to see authentication attempts to the server, including the user that tried to log in, the IP address of the connection attempt, the port used, and other information. Type last log. This command will show you the most recent login attempt for all users. To find the last login for a specific user, type lastlog-u followed by the username. You can use a combination of monitoring writes to the auth log file along with the last log command as tools in your arsenal to audit or monitor SSH connection attempts. If you are concerned that someone has accessed the server with a specific username, you can log into that user account and view their bash history file. This .bash_history file within a user's home directory will contain every command that was ever executed within a bash prompt. You can use this history of executed commands to further scrutinize any possible unauthorized SSH connection attempts.